In this video, I will discuss case 3 for the maximum path sum problem. Here, this particular case that I derived is an instance where this specific node itself, 20, is the maximum path sum. No matter what path we take, all of the paths will sum to less than 20. So this is the result that we should get. So let's prove that claim. First, I'm going to say that all of the null pointers from leaf nodes will have a sum of 0. If we go to the left, we see that that is -9. So now we're going to do our pre-order traversal. So we did pre-order, and then we're going to go down to -15. And we're going to see that this specific node simply has 15. If we do to the right, we say -7. And now we're going to do the element in the middle. The element in the middle has several possible cases. In the first case, we can say -15 minus -20 is -35. Now, if we want to do the middle and the right, and in this case this would allow us to go this way and continue, we would have 7 minus 20, and that gives us -13. We then have a third case where the path looks like this and doesn't continue up the tree. In that case, it would be -15 minus 20 plus 7, which would give us -28. And then we have a fourth case. And that fourth case in the subtree is the instance where -20 by itself happens to be the largest value, which would then cut out the sum of the subtrees. That doesn't work here, but this applies and will eventually help us solve later on. So we see that that is -20. So out of these values, we see that -13 happens to be the largest value. But we have another thing that we must consider. What happens if this were the entire tree and we had this solution? This would not actually produce the correct result. See that -35 is a solution, -13 is a solution, -28 is a solution, and -20 is a solution. But the actual solution we would want in this subtree is 7. Which is none of those. So we have to consider one other thing, the largest subpath. In this case, we have -15, 7, and 20. In that case, the largest value is 7. So there are two specific results that we need to propagate up the tree. First, we have this case where if we could actually use -13 in this case, to continue along the path. We also want to return the largest subpath. In this case, 7. So we need to tell the program that there is a subpath here, 7, that could potentially be the solution. But also we have -13 here to be able to continue a path. So we're going to return both of those values, and I'm going to show you how to do that in code. Finally, we consider the last node, which is the root node of 20. In the first case, it's just this plus whatever's coming from the left. So it's 20 minus 9, which is 11. The second case is the root plus whatever's coming from the right. And we see that the connected value is -13. We do not want to add 7 because this is not a valid path. Because in order to get to that path, we'd have to go through 20. So 27 should not be returned by the algorithm. In this case, case 2 is actually 20 minus 13, which is 7. Case 3 is the sum, where if this were a subtree, we would add all 3 of these. In that case, it's 20 minus 9 minus 13, which comes out to -2. And finally, the root node itself, 20. So we want to be able to compare the largest of those values and the largest of the two subpaths. The largest subpath on the left is -9. The largest subpath on the right is 7. And the largest path in the middle is 20. Therefore, this catches 20 as our solution. This algorithm also works if I were to replace this with 25. Because what would happen is this would get replaced with 25. This would become 5, but 25 would be here. And therefore, this would either return 25 with this result. So if I made this negative 21 and 5, or the 25, this path would actually be 24, excuse me. So therefore, if I made this 25 and negative 21, what would happen here is this becomes 25. 25 minus negative 1 becomes 4, and this becomes 25. And then here's what happens. On the right, we would have 20 plus 4 becomes 24, and this becomes the max of 24. But then the largest subpath would become 25 over here. So as a result, what would happen is 25 becomes 24, and this node here by itself becomes the largest maximum path sum. So this approach allows us to be able to catch all of the possible cases.